Good day, everyone. Myself Ankita Dixit, and with me co-author is Mr. Abhinav Dixit. We are independent authors from Noida, India, and title of our work is Smart Solution for Optimized Mass Customization Process in Smartphone Industry. And here's a table of content: the problem statement, mass customization, workflow methodology, sourcing and distribution, cost benefit analysis, and the future work conclusion. The problem statement states for our work is to deal with the dynamic customized demands of individual customer from varied segments and offer them customized solution by simultaneously achieving economics of scales. So to explain our work, first we would like to cover up the concept of mass customization. Basically, mass customization we can say as some business of the brand, they first observe the behavior and predict the preferences of the individual customers, and accordingly they make the customized product and the services and they deliver to the customers for their choices. Basically, we can say that mass customization is a marketing and manufacturing technique that combines the flexibility and personalization of custom-made products with a low-cost unit, and it allows customer to design made to order features. Like customer, they can order feature of their choices, and the most suitable technique that is used in mass customization is assemble to order, that is the ATO. Just to give a glance on what ATO is, it's a business production strategy, and the benefits of ATO is low inventory risk, increased flexibility, short lead time, rapid production of customized product. So products are assembled from the previously completed sub-assemblies, and whenever a new customized order comes to the business or the brand. And the next is our workflow methodology, and this covers three main phases. The phase one is the smart identification of usability features, optimized solution of similar but not same usability features, and detection of aesthetic features, predicted demand of each possible feature set. Basically, these three phases are the USP, or you can say the heart of our research work, and my co-author Mr. Abhinav Dixit will now explain these phases one by one.
So thank you, Ms. Ankita, for giving me platform to explain the workflow methodology for our research work. So has already been given an introduction about what all phases that are included. So I will be giving a brief walkthrough over the phases that are involved. So the first phase that involved is about the smart identification of usability features. Now, if we'll talk about the base level of what it is about, so when a mobile device has been created, so ample lot of hardware and software combinations can exist while we create or when we manufacture any device. But at the same time, not all features that are available or what not all the possible hardware and software combinations they're practically possible. For example, if we talk about a mobile device who needs to be having a 6 GB or say 12 GB of RAM, so they cannot have a space of a lesser amount, or they cannot have a features of a lesser amount. So they need to have a better upgrades in the configuration. Only then such kind of features can be supported. So it gets very important to identify what all are the possible hardware and software components which are feasible. So on that note, if we'll give a view on the equation that has been given. So here the M stands for the number of hardware components, N stands for the number of software components, and the variable X and Y are the possible combinations of hardware components that are possible, and Y stands for the possible components for the software are possible. But this is on a generic level. However, if on a practical basis, if we talk about, so all possible combinations already been said earlier are not technically feasible at all. And if we'll sit and we'll try to find out all these features and then try to eliminate the one which are not required, it is practically not possible, or rather it is a very time consuming activity. So hence the keyword smart identification comes into picture. So let me give a walkthrough of what smart identification is. So it's like uh, we are trying to take all the possible combinations of hardware. We're trying to take all the possible combinations of the software and what all constraints that are available, and then we come out with a variable k that stands for the total number of feasible combinations which are actually possible. So this is done by this is automatically been done so that we get a final output where we have all the possible feasible combinations of the hardwares and the softwares done automatically without a manual intervention. So this is all about our for phase one. Now moving on to the next phase, that is phase two. Here it talks about optimized solution of similar but not same usability features and detection of aesthetic features. Now the base of the phase two talks about clustering. What clustering is all about is it is a task of grouping a set of objects in such a way that objects in the same group are more similar to each other than those in other group. So again it talks about similar but not same. So what happens is after doing the exercise in the phase one, when we are out with the feasible combinations of identified, then the customer's similar preferences are grouped to form the clusters in order to achieve cost reduction and the optimization. Now, what we see here in the figure is about the clusters that we have, and they are the data points. So data points here we refer to as the number of users or the users which are there. Now, if we see the distances which are between the data points, they can be similar, they cannot be similar. And what all these represent is as a similar specification if we talk about a one specific cluster which are there. Hence, so the distance between, this is what has been written, the distance between any two similar data points within a cluster is generated by an aesthetic feature. Now what differentiates things in what differentiates actually the data points is the aesthetic features. What aesthetic features basically could be, if we'll talk about in a mobile device, then it could be tempered glasses, or it could be the quality of back cover material, or are we about the quality of the earphones. So these all, everything adds to the aesthetic values of the mobile devices. So hence, it's about finding the optimized solution for the similar but not same usability features, and on the basis of that we do the groupings, and on the basis of groupings we identify the similar users, similar data points, and then and they are differentiated on the basis of the aesthetic features. Now coming to the last phase, this is about predicting demand of each possible feature set, and it is done using SMOT algorithm. And what SMOT stands for, it is synthetic minority oversampling technique algorithm. Now what happens, we have seen previously that we have clusters and clusters have the data point. Now no, on a practical scenario, if we'll talk about, no two clusters can have same number of data points. So homogeneity will not be there. And if we'll try to do prediction, then the predictive value will never be same, because no two sample size are no two cluster size are homogeneous compared to each other. So on the basis of that, SMOT algorithm has been used. So it is basically an oversampling data augmentation algorithm technique, which is used to fill each clusters with same number of elements, so that the sample size can remain same across each clusters. So if we'll see about this equation, so Ci, Cj, they are the clusters which belongs to K, and what K is, the feasible combination that we have found in the previous phase, and Pi, Pj are the augmentation factors which are added by this SMOT algorithm to make the sampling or to make the clusters same to make the clusters homogeneous across our production work. And hence, this is what it is. And if we'll talk about determining the demand based on the historical purchase, then the historical purchase is about if we'll try to look into the purchasing pattern of the customer, how they are purchasing and what kind of features they are requesting, or what kind of work they have been doing, research work they have been doing while buying any mobile device, or requesting any specific features in a mobile device. So that all gets come under the heading of the historical purchase. So if we'll talk about this equation, so here the variable x, it are the historical purchases from the sample set of clusters, and the factors S is the sales of the smartphone that will be increased based on the industrial growth trend. So therefore, if we need to find out the demand of mobile in the current year, so that would be 100 plus S divided by 100 into X, where 100 plus S is a percentage change, and S is the factor of increase, how much the sales has increased, and X with respect to the historical purchase from the sample set of clusters. And if we need to find out overall demand in a cluster, then it would be Ci plus Pi, where Ci is the cluster for and Pi are the augmentation factor, and for all the possible feasibility combination that we have into the overall current demand. So hence by this we will be able to find what all possible prediction for specific features are there in a mobile device that a user has asked for, and simultaneously and eventually the concept of mass customization can be implemented. Now moving on to the next part is about the sourcing and the distribution. Now we have analyzed, we have seen that what all work is being required to do an initial prediction of the work, to find out the feasible combinations, to group to group the customers into a similar set of clusters, and then find out or predicting the demand as per their needs. So on the basis of that, now it's become very important to do the sourcing and the distribution of the work. So now, as we discussed in the previous slide, so sourcing and distribution, it act as one of the key heart of the work done, because if we manufacture the work, if we manufacture the products, if we identify the end user demand, we do the forecasting, but if our distribution network is not efficient enough, then it is will not be able to give us the output that we seek to have from the customization of the mass customization, or we can see the volume manufacturing that we are doing. So hence the mass customization very peculiarly talks about the concept of economies of scale. So on a layman language, what economies of scale stands for, it is like the proportionate saving in cost which is gained by increased level of production. And as already been discussed in the previous slide, here we try to do manufacturing of the products as per the demands of the customers, so that uh, using maybe the bulk production, or as I will be covering the next step, so that we have an increased level of production, keeping the cost minimum as much as possible. So there are two ways we can achieve the economies of scale. The step number, or the way number one would be that the smartphone manufacturing company, they can do mass production of the components or the modules by themselves, because this will anyhow coming out to be economical for them when they'll go for the bulk production, because they go for the bulk purchase, bulk acquiring of the raw material, which anyhow adds to the discount to them. Or the second option could be the manufacturing work, they can be outsourced to the third party, so that they can manufacture the component in the large volume, and the smartphone companies, they can just do the assembling of the final product. So hence Economies of scale, it occurs from the operational efficiencies that improves with the increase of scale of production. Now, as discussed, like the main sources of how we can achieve economies of scale, either it could be doing the bulk purchase, or we can do improvement in the management quality, or in the utilization of technologies that we are using so that we can have increased efficiency or the supply chain distribution. Now, if we'll talk about the sourcing approach, there are we can have we can see a sharp difference between what a traditional approach was doing and what mass customization approach will do. So, in traditional approach, what is doing? Say we have two modules X and Y. They are produced by a third party. Then they will be given to firm A, and firm A will be using say module X to produce their end product P1, or module B will use product X to produce P2. But in mass customization, a single product will be common module will be produced so that both the firms A and B can use them simultaneously. So there is no work involved when two different vendors will be working. It's like the same will be work across the firms to produce their end products. And then once the work has been done, it becomes important to do the distribution function. And for distribution, initially what the things were there was one single supply chain model, but we need to focus on the simultaneously many supply chain so that the concept of modularization can be achieved, so that we can with mass involved basically reaching out to many people, and mass customization distribution is what we have customized and what we have produced. We need to distribute it the same. So if we'll talk about it, just a basic supply chain flow chart is there, that we have raw materials go to suppliers, then go to factories, then to distribution center, from distribution go to retail and to the end customer. Now this is a single chain. To have a mass customization, we need to have a modularization, where we need to think about how we can do simultaneously or parallelly. We can work on the say trays, on the containers, the vehicles, or the warehouse distribution center, so that we can have all kind of demand that is being asked by the end user, so that uh, they can be delivered effectively. So on that note, I would like to give platform to my author Ankita Dixit, so that she'll talk about the cost and benefit analysis of mass customization. Thank you.
Thank you, Abhinav. Now, covering the cost benefit analysis, basically, when we are in a phase to decide that whether for a product we should go for the mass customization or not, then cost benefit analysis is done. So, generally, what the business like firms do, they practice the mass customization. First, they ensure that cost advantages should be obtained due to their scale of operation, with cost per unit of the output decreasing with the increasing sales. So basically, there are two factors that are being covered. One is the cost saving and one is the additional activity cost. So as per the slide shown, cost savings, they have few parameters, and additional activity cost, they have some parameters. These are all basically the mathematical figures that are calculated based on the market review and other factors. And based on these mathematical calculations, decision is done whether that mass production will be done for some product or not. So you can say, if savings due to economies of integration is greater than additional cost of mass customization, then only firm will decide that they will pursue for the mass customization. Otherwise, they will not pursue for the mass customization. Now, coming to the conclusion and the future work, well, mass customization has proved to be a path-breaking approach in many industries, and like fashion, footwear, computers, mobile, and still expanding. And smartphone industry is one of such industry which have a very big potential customer base for this approach. to be used. So our future work involves the simulation of our proposed work, and we are further doing the research study for more efficient AI-based algorithm. Currently, the algorithm that we have used is Mote, and we are working like how better we can enhance this current existing algorithm, and yes, how can we expand this particular idea of the mass customization in various other fields. And with this, we end our presentation. Thank you so much. Thank you.